Okay, welcome back. This is the third video in the OCR GCSE Computer Science tutorial series. This is paper 2, part 2. You'll note that in the previous two tutorials I talked about study techniques. So I'm going to link to learning scientists, and the technique I'm going to talk about today is elaboration. What is elaboration about? Elaboration is asking yourself why or how something works. In computer science, for example, you're told that MAC addresses, that's a media access control address for any device on a LAN, is 48 bits, 48 binary digits. However, it's stored in hexadecimal. Well, why is that? Well, hex is going to ensure that you can store it in 16 values instead, because one value in hex is equivalent to 4 values in binary. So one is going to be shorter, thereby making it easier to remember, easier to write, easier for people to read. And also it's easier to convert between binary and hex. But this technique of elaboration also helps you understand any topic. Take, for example, English, and you're studying Macbeth. So in Macbeth, he says, "Is this a dagger I hold before me?" And you might question, who is he saying that to? Why is he saying it? How does he feel when he's saying that? So, for example, is he saying it because he's preempting his guilt? Is he saying it reluctantly because he's being forced to do something by Lady Macbeth? Is it because he's hallucinating? Is he creating some kind of excuse for what he's about to do, as though he's confused or unwilling and reluctant? So the process of elaboration helps in all your subjects, questioning why something works, how something works. It is important for all your subjects. And once again, I'll link to the Learning Scientists posters so you can have a look at those. But we'll move on, and what we're really here to do is to talk a bit about some of the key techniques in paper 2 and paper 1. So here we're going to look at this array again, and we're looking to see how we find the lowest number. What we should always do then is we should always have a hypothetical lowest number, and we'll say that that lowest number is going to be, for sake of argument, the first value in the array. So num0, yeah? So it's going to be 9. Then what we can do is we can loop through our array. So for count, and you might put for count in range num.length, or you can put for count in range 0, 6. I'm going to put OCR pseudocode, so for count equals 0 to 5. It doesn't really matter which one you do, the examiners will mark all of them as correct. And then we'll say if num, and we'll index count, is lower than lowest, then we're going to update the lowest value and say, well, the new lowest is now equal to num count. Okay, so it's going to loop through from 0, 1, 2, 3, 4, 5, 0 to 5. It's going to check if the current amount is less than our lowest, which is 9. And then it's going to say the new lowest is equal to num count. Theoretically speaking, we can actually start at 1 because we already know 9 cannot be less than 9. I mean, it's the same thing, isn't it? So we might as well start there and start comparing. After we've finished our for loop, we can say print, and we'll give a meaningful message. We'll say the lowest number is, and we'll concatenate that with lowest. Yeah? So that would be that the solution to finding the lowest number in an array. Let's move over now to binary and hex. So what you should be thinking about in binary hex is, first of all, you're not going to be given a conversion table in your exam. So what I would do is I would just write down on your margin this in your exam: 9, 10, 11, 12, 13, 14, 15, 9, A, B, C, D, E, F. That's meant to be a B. Okay, so here then, we take our, what we call our binary bit pattern, and we split that into 2 nibbles. That's a byte. When we split it into half, each 4 bits becomes a nibble. 100 goes in that side. 1010 goes in this side. And then we can start converting. Well, actually, on this side we've got 8. On this side we've got 8 and a 2. Add them together, we've got 10. So that is 8a. You could do the same here as well. We split our nibbles. You might want to pause the video and do it yourself. But we've got 1111 on this side, 1110 on the other side. 8 plus 4 plus 2 plus 1 is 15. 8 plus 4 plus 2 is 14. Using this, we can see it is FE. Working the other way, it works as well. So over here, you've got 9B. And you might be asked to go to binary first and then to denary. So we'll put 9 as one nibble, B as the other. We'll put in our bases, 1, 2, 4, 8, 1, 2, 4, 8. 9 becomes 1, 0, 0, 1. B is the equivalent to 11, which you should have on your previous sheet. So you'll have 8, 2, 1. So that would be the binary. If you want to find the denary, you just need to make sure your bases are binary bases. So you're multiplying by 2 each time. That's what the prefix bi means. Like binoculars, bicycle, bicep is 2 muscles. We'll go 16, 32, 64, 1, 2, 8. And then here then you've got 128 plus 16 is 144 plus 8 is 152 plus 2 is 154. So that should be your answer. Okay, so next then we're going to move on to 2D arrays. I'm going to dedicate this to some of my hardest working students that I've ever taught. So I'll give them a special shout out. Obviously, this is not all of them because I have, at least 50 or 100 that should be in this list. But it'd make the 2D array too big. So in this one then, it tells us how the 2D array is indexed. So 2, 3 is 99. So I find 99 and I figure out that that means that if we were to write this out, 0, 1, 2, 3, 3, 4, 5. To get to there, 2, 3 means that the 2D array is indexed by row and then column. So if I want Carmen's first exam result, Carmen is in row 4. So we're going to go print CS scores, and then we'll go 4, and then her first exam, her name's in 0, her first exam is in 1. There. Yeah? What you'll notice then is that this is just a visualization. What that means in your exam, you might be asked what's the word visualization means. That means that the 2D array is not stored in a table form. This just helps us to understand it better. The 2D array is actually stored as such, and it can be written all on one line, really. And you'll see that because it's an array, all the data types have to be the same. So if you've got numbers in there, they're going to be stored as strings. If we're going to output the average for each student, then what we need to do is we need to do a nested for loop starting with our students, because it's the average for each student. So we'll do for student equals 0, 1, 2, 3, 4, 5. For student equals 0 to 5. You might write for student in range 0, 6 if you're writing Python. And as I've said previously, you can do that in your exam. They'll mark it as correct. Then we'll say, actually, right there, we can actually set the total to 0. So here we might say the total equals 0. Then we'll say for each exam, for exam equals, and they've got 3 exams starting at position 1, 1 to 3. In Python, you'd write for exam in range 1, 4. Some people ask, why can't you write for I in range? You can, but these are much more meaningful. And when it comes to write out your answer, it's going to be a lot better. So for each exam, what's happening then is the total is updated. So total equals total plus And then because these are strings, we're going to have to convert them to integers. The int of CS scores, and then we're indexing the student by the exam. Yeah? Then we can say the average. So once we've done that for all three exams, we can say the average is equal to total divided by 3, because you've got 3 exams. Now theoretically, it might actually be better to write total equals 0 here. It doesn't matter, it's going to do the same thing, but if you're reading it, it's easier to read if you reset your total after you've output your average. So all this is doing is resetting your total back to 0. So when it goes to the next student, it's going to start again, count from 0. So once it's finished with Yaqub's average, goes to Kamal, and it's going to start with 0, plus 91, plus 95, plus 89, divide by 3. Then we're going to print out each student's average. We might make it a meaningful message, so we might say print, actually, let's take out the speech marks because we're just going to say the actual variable. So we can say student concatenate with apostrophe s, so their average, students average equals concatenate, and this time we're concatenating the average, yeah, the average variable. So there, what we've done is we're looping through every student for each of their exams, 1 to 3, not 0 because 0 is their name. The total's being updated. The average is a total divided by 3 because they've got 3 exams. Reset the total, so when it goes around for the next student, it's going to reset the running total. And the student's average is equal to average, and we're concatenating there with comma. Okay, next then, if we move on, I'm just going to fold this up. You might want to pause the video and have a go at these yourself. So write a procedure which takes an argument, takes as an argument a person's name. The name is found in the 2D array, should then output all their exam scores using a meaningful message. If their name is not found, a meaningful message should be output. So the first thing you need to think about is the name of our procedure. So you can either do def or you can put procedure. So we'll put def student scores, and we'll take as a parameter the name, so that the argument is passed into this parameter called name. Because it's a searching algorithm, we always put a Boolean flag, so we'll say found equals false, and that lets us say later on if found is still false, then we can say the name's not been found. So then we're going to do our for loop. So we can say for student, you can put for student in range 0, 5, or if you're writing OCR pseudocode, you can say for student equals 0 to 5. Actually, Python should be 0, 6, but we'll put 0 to 5 because we're doing pseudocode. For student equals 0 to 5, we'll say if the name matches is equal to CS scores, and what we need to be very careful of here is we're going through each row. So the row is called student, and the position is position 0. Yeah, because this is 0, 1, 2, 3, 0, 1, 2, 3. So we're checking if that is found, then effectively found equals true. The Boolean flag is set to true. Then we can output their scores. So we can say it should output all their scores. So we'll do a print, and we can say name concatenate exam equals, oh, that wasn't really necessary, that comma, but that's fine. So names exam equals, and then we'll concatenate in their exam score, which is going to be at CS scores. So here, if we're trying to output all their exam scores, what I actually need to do is I need to go through each exam. So it's not asking for a total, it's asking for each exam. So I'm just going to rub this out. And you'll notice I do this pretty much in every video. I make a mistake. I'm human, and I don't program that well without an IDE. So I always have to double check my answers. And as I'm writing it, I'm thinking through it. I'm thinking, wait a minute, I need to find out each exam. So when I found is true, I need to do my for loop. So I need to do for exam equals 1 to 3, because I need each of their exam scores. I want to print out their exam. So we'll do student concatenate apostrophe s their exam, and then we'll concatenate in the exam number. Exam, concatenate in exam number, concatenate in the equal sign, and then we can concatenate in their current exam. So it'll be CS scores, and it'll be student exam. Just fit in. We don't need to necessarily cast this as an integer or anything. It's a string. We can just output as a string. So for every exam, we're saying student's exam, their exam number, is equal to whatever their score is. And then we need to say, okay, so that will work. So for every single student that's found, we can say that their exam is going to be, their exam scores are going to be output like that. However, if they're not found, so if found is still false after we for loop through all of the students, we can say if found equals false, then we can print student not found. It's worth noting at this point that if, say, for example, here it's asking you to write the procedure, so this is how we would write it. If they actually ask you instead for how you would use a procedure that they've already defined, which does all of this, then you would actually have to say, in order to use it, you would do name equals input, enter student's name, and then we call the student scores procedure, and as an argument we're passing in name. So that would be how you would use it. So it might say a procedure which takes as an argument a person's name will find their name, and if it's found, their scores will be output. If it's not found, a meaningful message should be output. Write the lines to use the procedure. This is how you would use it. If it explicitly asks you to write a procedure or write a function, that means you need to do this. If it says how would it be used, that means you need to do this. Okay, the last thing we're going to talk about in this video is file writing, which comes up on both paper 1 and 2. So here it says current date time is a function. So they're saying it already exists, which returns the current date and time. The following algorithm is used to record when a person last logged in and to update an existing file. Rewrite the code so statements in the correct order. This type of problem is what we call a Parsons problem, because you're just reordering code that's already given. Now, we know that even if you get a file writing question, you're not sure what to do, we know the last line on every file writing question is generally the close. New file dot close, and you'll get a mark for that. So we might as well write that in now. Before you can do anything, you probably need to open your file as well. So let's do new file equals open here. Our argument is the file name, so login datelog.txt. Because it's updating an existing file, that's why it's in append mode. Usually if you're making a new file, you'd use write, and if you're reading a file, you'd use read. So that's the syntax. New file equals open, the file name, and then append, read, or write. Before we can write details, we're actually going to have to define it or initialize it. So this initializes an array, an empty array called details. We can then generate our log time using the current date time function, which is given to us. And then what we can do is we can append our username to the array, because we need to know their username. And then we also append to the array the log time, or the current date time, which is stored in log time. And then the last thing we do before we close the file is write. So in order to do that, use new file, the function is called write, and we're going to write our array. In Python, you actually need to cast that as a string, but here, I mean, they've given you it as the Parsons problem anyway, so we'll just write in the array. But just bear in mind that in Python, you'd have to do new file dot write and then str of details. But effectively, that is file writing. I hope that's been helpful, and in the next video, we're going to look at functions and also some SQL as well. So functions that return values, SQL, and we might do a brief recap on data types and also Boolean statements. That's it.